Welcome to video lesson 7.4 on approximating square roots. In this lesson, we're going to look at how to approximate the value of irrational square roots. So not every square root we try to find is going to be one of the perfect squares, where it has two integers that multiply together to equal that square root. There are lots of square roots that are irrational, or what's known as numbers that can't be written as a ratio of two integers. Okay, the square root of any whole number that's not a perfect square is irrational. So we have the square root of example 9. That's going to be 3 because 3 times 3 is 9. But the square root of 10, that is going to not come out to a rational number, because if we put the square root of 10 in our calculator, we're going to get 3.162277766, and it's going to continue on in a pattern that does not repeat and never ends. Okay, and that's what it says here. The decimal form of an irrational number neither terminates nor repeats. So this would be rational, the square root of 9, because we have the integer 3 that it equals, and the square root of 10 is irrational because it's approximately 3.16, and I could continue on 2277766, but that's all that the calculator shows me. It continues on, the calculator just only has room for that many digits. Okay. Now, rational and irrational numbers together, they form the set of real numbers. Okay. This next diagram is something that's very helpful. I would suggest making sure you write that down in your notes. And it gives you all the different classifications of real numbers. So real numbers can either be rational or irrational. Okay. If it's irrational, that's pi. Any decimal that doesn't repeat, any decimal that never ends but doesn't have a repeating pattern is irrational. Okay, so the square root of any not perfect square would be irrational. If it's irrational, that's all it's going to be. If it's a rational number, okay, if it's a fraction, and you can only write it as a fraction, you can't simplify it at all, then that's all it can be too, is rational. But if it would be a fraction that you could simplify to an integer, so if it's positive or negative, it's an integer. If it's a positive number, okay, then you can call it whole. And if it's any number that is greater than 0, it's also a natural number. Okay. So if you would have the number like 2, then all the categories that would fit into, so of course it's a real number, but it's a natural number, it's a whole number, it's an integer, and it's rational. So if you get a basic positive whole number, that classifies as a natural number, a whole number, an integer, and a rational number. Those are the all 4 subsets that you would need to define them as a real number. So example 1 asks us to classify. So we're going to name all the subsets that it works for. Now, the square root of 14, does that come out evenly? Okay, the square root of 14, no, it's 3.74165738.7. Okay, still, this is irrational. Okay, it's not a perfect square, so we know it's irrational. Now, this line above here means that it's a repeating decimal. Repeating decimals are rational numbers. Okay, but it can't be written as an integer, so we just keep it because it would be not written as an integer. Tomorrow's extension will learn how to write this as a fraction, a repeating decimal as a fraction, but it's only a rational number. Now, the negative square root of 9, well, that really equals negative 3. Okay, so that's rational, and it's also an integer. Okay. If we wouldn't have this negative out in front, then we would call it a whole number and a natural number. Okay. Now, 72/4, that actually equals 18. So that's a rational number, an integer, a whole number, and a natural number. Okay. And pi is irrational. Okay. It's a decimal that never ends and doesn't repeat. Now we want to estimate the square root of 71 to the nearest integer. Okay, what you're going to want to do, the easiest way to do these is just take your calculator, type in the square root of 71, and you're going to get on the calculator, square root of 71 equals 8.426149773. Okay, so to the nearest integer, 8.4 rounds to 8, and to the nearest tenth, 8.42 rounds to 8.4. Okay. Now, which is greater, the square root of 5? Okay, the square root of 5 on your calculator is approximately 2.23606. Probably don't need to do any more than that. And 2 2/3, okay, that actually equals 2.6 repeating. If you would put it in your calculator, it will give you 2.66666, a bunch of 6 and then a 7. It's just that it rounds that last number on your calculator. But 2 2/3 is 2.6 repeating, so the 0.6 is greater than 0.2. So which is greater? 2 2/3. Okay, since 2.6 repeating is greater than 2.236, and so on. All right, example 4 says the radius of a circle with area A is approximately the square root of A divided by 3. Okay, this should go all the way across here, sorry. The area of a circular mouse pad is 51 square inches, and we want to estimate the radius to the nearest integer. All right, so let's write down what we know. We know the area, okay, is 51. So we need to do the square root of 51 divided by 3. And 51 divided by 3 is 17. So we need to find the square root of 17. Type that in our calculator, and they want it to the nearest integer. So that is approximately 4.123. Continues on with some more numbers, but I just need this here to let me know I'm going to round that down to 4. Okay, and that would be inches. Then is my radius. One more example. It says the distance in nautical miles you see with a periscope is 1.17 times the square root of the height, where the h is the height of the periscope above the water. And it asks, can you see twice as far with a periscope that is 6 feet above water than with a periscope that is 3 feet? So what we need to do is first, if our height equals 3 feet, okay, we're going to evaluate this 1.17 times the square root of 3. Okay, and on the calculator, that's going to give us approximately 2.03. Okay, and the height being 6 feet, and then we're doing 1.17 times the square root of 6, and that's approximately 2.87. Okay, and if we would divide that out, 2.87 divided by 2.03, that is only approximately 1.41, not 3 times. Okay, so we can't see, or not 2 times, so we can't see twice as far if it's twice as high above the water. So no, since 2.87 divided by 2.03 is not 2. Okay. Really, you just need to use your calculator quite a bit today, except for the classifying the real numbers. Please make sure you write down any questions that you have. I'll be happy to answer them at our next class. Thank you. Have a great day.